Raise your hand if you relate to this. Okay, hi everyone. Thank you for the introduction. As mentioned, my name is Nadia. I want to start by quickly telling you a little bit about myself. So I've been a developer for a very, very long time. So I worked in for a few years in Atlassian in different teams, from design systems to a product that some people might know and sometimes love, called Jira. Then worked for a few years at a small startup as a founding engineer. Then I tried to do my own thing, and for the last few months, I've been on sabbatical, focusing full-time on my writing and educational activities. I'm a little bit lazy, and also I love traveling. So as a result of this combination, I managed to relocate for a few years from Australia to Austria, just because it was easier to spell. I am a little bit of a nerd, and one of my special hobbies is investigating everything I can about front-end performance and React. Also, my second special hobby is explaining things in writing. So combining those two together gives you my blog with a whole bunch of articles on those particular topics, and even 2 books, you guessed it, on the topic of React and performance. Woo! So if you ever heard the words React and performance in the same sentence, the discussion was probably about re-renders or memoization, or probably both. And in the last few years, opinions started popping up that those topics, memoization and re-renders, are completely solved problems thanks to the tool known as React Compiler. Which finally brings me to the actual topic of the presentation, not me, but React Compiler. So is it true that the problem of re-renders in React is completely solved? And can we forget memoization now, thanks to the compiler? We're going to find out today. So the structure of the talk is like this. What is the problem with re-renders and memoization, and why we introduce yet another tool to solve them? What is this compiler to begin with, and what can we expect from it? We're going to check out how it works on a few simple examples. And finally, we're going to test the compiler on the real code, see some numbers, and do a little bit of investigation. By the end of the talk, hopefully, we can answer this question. Can we forget memoization now? So let's start with the problem. What exactly we're trying to solve? Here is a really beautiful web interface. It looks really nice. When some new information comes in, we want to update it. To do this in React, we trigger what is known as re-render. Re-renders in React are cascading. Every time a re-render of a component is triggered, it triggers a re-render of another component, that triggers a re-render of every component inside, and so on and so forth, until the end of this component tree is reached. If those downstream re-renders affect some really heavy component, that might cause performance problems. The app will become really slow. To fix this, we need to stop this chain of re-renders from happening. One way to do it is to tell React that this particular component doesn't change, and React can skip its re-renders and every component that is rendered inside of this component. There are multiple ways to do it, of course, as everything in React, but memoization is one of them. Memoization usually starts with a React memo, which is a higher-order component given to us by the React itself. It wraps our original component like this, and then is rendered on its place. Now, in this code, when React reaches this component in the tree, it will stop and check whether its props have changed. If none of the props change, then re-renders will be stopped. If even a single prop changes, React continues with re-renders as if no memoization happened. That means that for the memo to work properly here, we need to make sure that absolutely every single prop on this component stays exactly the same between re-renders. For primitive values, like strings, it's really easy. We don't need to do anything other than not changing them. For arrays, objects, and functions, however, they need some help. So React uses referential equality to check for anything between re-renders. And if we declare those non-primitive values like this inside a render function, they will be recreated on every re-render. Reference to them will change, and then this prop will change, and memoization of the very slow component will not work. So to fix this, we have everyone's favorite hooks, useMemo and useCallback. We would wrap arrays and objects in useMemo, like this, and then functions in useCallback. Those hooks will preserve the reference to the values between re-renders. So next time re-render in the parent component happens here, nothing here changes, no prop changes, and a very slow component is not going to be re-rendered. This is slightly simplified explanation, but as you can see, it's already quite complicated. So anyone who used those hooks in real life knows that it's really hard to trace those changing references and how quickly our apps, our beautiful code that we write daily turns into an incomprehensible and unreadable mess of useMemos and useCallbacks. So solving this situation is the compiler's main promise. Sorry. So let's take a look at the compiler itself. What exactly is it? Or let's start with what it isn't. So the compiler is not part of React 19, despite the really widespread belief that it is. In fact, it's an independent tool that just happened to be developed by a React team. Also, it's not tied to React version as well. All the versions are just fine. No need to rush to update everything. It will work. The compiler is a Babel plugin, so it's part of your build setup. Those plugins are code transformers. So they take the beautiful React code that you write daily and then transform it into an improved version. If we, in case of the compiler, it transforms the normal code, normal React code like this into code where components, their props, and hooks dependencies are memoized by default. Almost like this. Almost, because not exactly. So the code behaves this way. It's a really good mental model for debugging, but it's actually much more complicated than this. The compiler doesn't blindly just wrap things like that. It tries to be smarter. So for example, something as simple as this component will be transformed into this. Notice how onClick here is cached at the very bottom, but the data object is not really cached, but it just moved inside if statement. If, however, I reference data inside this onClick over there, the compiler understands all of this and then completely rearranges the code. So the mechanics of how all of this is working are really fascinating. React team created a few videos that just walk you through how it works. But in my case, I'm really interested in practical applications of this miracle. So more specifically, whether our expectations of the compiler match the reality. And as for reality, the main question that immediately comes to mind to almost everyone is, what about initial load performance? So one really big argument against let's memoize everything by default has always been that it can negatively affect initial load because React now has to do many more stuff in advance when everything is memoized. Will it actually have a positive impact at all? So how much of a problem those re-renders really are? Can it catch all re-renders? JavaScript is notorious for being fluid and ambiguous. Is the compiler smart enough to really catch everything? Is it true that we will never have to think about memoization and re-renders ever again? Before answering those questions,
I want to really quickly check out the compiler on a few synthetic examples and see how it works. Maybe it doesn't work at all, you know. So first one, we have a case of a component with a dialog inside. We have state for this dialog. We have a button that can open this dialog, and then a very slow component somewhere underneath. Let's say it takes like 500 milliseconds to re-render this very slow component. In case of this component, a normal React behavior would be to re-render everything when the state changes. As a result, the dialog pops up with a big delay because of the very slow component. If I wanted to fix it with memoization, I would just need to wrap very slow component and memo and render memoized version instead. So let's get rid of the memoization and enable the compiler instead. I implemented a really complicated app for this. In the dev tools, you can see that we have a bunch of magical memo labels appearing. That means that the compiler for this particular app is working, and those components, including the very slow component, are memoized by the compiler. Now I just need to verify that very slow component doesn't re-render anymore, and a simple console log can just, inside useEffect, can take care of that. And then if I click on the button, what I will see that only the button itself re-renders and the dialog opens instantly. So this is a score 1 for the compiler. It worked perfectly. Let's try something more complicated. Let's now add some props to the slow component, like this. So it's a standard stuff, object and a function. If I wanted to memoize it, I would have to go with the classic trio: useMemo, useCallback, and memo. So this is how memoization hell starts. Getting rid of all of them again, and turning on the compiler. Again, clicking the button, and again the same situation. Only button re-renders, the slow component does not, the dialog pops up instantly. Another win for the compiler. Really good job. Final case before diving into the proper code. Let's try something even more complicated. This is my favorite example. What if the very slow component accepted children, like this? Off of the top of your head, try to think how would you memoize it, and I will give you a second. So who thinks it should be this? Shame on you, because it doesn't work. Even if you didn't raise your hand, probably was slightly scared, because I know for a fact that even very senior developers sometimes think that the solution is this. Unfortunately, this is not going to work, because children here are nothing more than syntax sugar for a prop named children. If I rewrite the code like this, it will be exactly the same. This prop, children, contains an element. This element is the child memo that looks like an HTML tag. This is, again, nothing more than syntax sugar for an object of this shape. The HTML-like syntax is yet another code transformer that we just usually don't think about. The object itself here is non-memoized. It just references the memoized function within its type. So essentially what we have here is non-memoized prop on a memoized component. The very slow component memoization will not work, and it will re-render with every state change. To memoize it correctly, we need to do this. We need to memoize the object itself with useMemo. So the pattern is probably the most counterintuitive pattern in React ever. So don't feel shamed. But let's get rid of this, and we'll see how the compiler handles it. Can I have a drum roll? I'm clicking the button. It works. Same story as before. The dialog pops up instantly, no very slow re-renders. The compiler performed beautifully. So that is impressive. But isolated examples are kind of easy. Time for test drive on the real road. The real road looks like this. I implemented an app. It's completely new, fully TypeScriptified, no legacy code, nothing. Only hooks, everything is best practice. More or less, because as you know, I'm a little bit lazy. So the app has a few pages, and in total, it was something like 15,000 lines of code. So not the largest app ever, but good enough for a proper test drive. Before turning on the compiler, I ran the health check and the ESLint rules provided by the React teams. You can find them in the docs, how to set up all of this. Those are the health check results. Almost everything is compiled, no usages of incompatible libraries, and then 0 ESLint rule violations. And finally, I haven't done any performance optimizations yet, so please don't judge me when you see numbers. So exactly so I can try the compiler for this talk. So the app is as prepared for a React compiler as it can possibly be, including some serious and known performance problems to fix. Now, testing conditions. I used Lighthouse to measure the performance values. I did all measurements 5 times. In the presentation, I'm actually showing an average. I did all the runs on production build in the mobile mode of the Lighthouse. So the CPU was slowed down from my normal laptop at least 4 times. So now let's start answering questions. First one, does the compiler affect initial load in any way? So the first page that I measured is the landing page. It's beautiful and really, really long. It's like a proper landing page. Without the compiler, the stats for the initial load look like this. Slightly meh, but again, no judgment here, please. In any case, I'm more interested in the relative numbers than the absolute numbers for this case. So now enabling the compiler, checking that in DevTools, a whole bunch of memoized components, so it's working. And here's the difference. Or to be precise, no difference at all. Numbers are pretty much identical, which is really great because the compiler didn't make things worse. It's not supposed to improve initial load performance. We just hope it doesn't make it worse. So to be completely sure, I ran it on a few more pages, and the results were more or less the same. Some numbers would slightly increase, some numbers would slightly decrease, but no drastic changes. So I'm going to add another point to the compiler and answer the first question. Yeah, it's cool for initial load, no negative impact. Second question, and basically the reason for the compiler to exist. How much of an impact it will have on interactions performance? Let's take a look at another page. The app that I'm trying this on is basically a showcase of UI component library that I was working on. So here we see a preview of a very, very large component. In fact, the whole settings page within this preview, like a block. And at the very top, I have a dark mode switcher. So if I activate it, if you see those blue lines, that means re-renders of everything happening here. So React DevTools highlight re-renders here. The numbers for this particular interaction of switching light mode is this, which is really, really bad for this simple interaction. It's like completely red. So let's enable the compiler and and see, and wow. OK, so that is impressive. I hope you agree. Well, it's not for me, but for the compiler, come on. You're encouraging the robots. What's wrong with you? Actually, that is way too impressive to be true for my suspicious nature, because how exactly did this happen? I'm not that bad of a developer to mess up that badly. So let's investigate. OK, I forgot the emojis. Yeah, that's me thinking. Let's investigate. The answer is somewhere here. This is the code for this preview page. That thing here renders the preview of the entire settings component. So the settings thing is just sent to it as a string. It transpiles it, and then renders it back. So the entire page that you saw in front of you is just a tiny component.
What we have here is literally the synthetic example that we looked at earlier. Very slow component with some minor props. Which is cool that the compiler was able to pick it up in a real code. I'll add another win to it. But also, it feels a little bit like cheating and playing it in favor of the compiler. Because the clear situations like that are really rare. In real life, we probably will have a bunch of small-ish components, and the job for the compiler will be much, much harder. The next page is much closer to the real life. I have a header with some stuff, I have a footer, and a long list of cards in between. So it looks like this, long, long, long. Quick filters at the top control which cards are shown. So if I click on a button, it will show me components with buttons. If I select a checkbox, it will add components with checkbox to the list. As you can see, as you just saw, without memoization, everything just re-renders. Those are the numbers before any optimization. Performance of adding checkbox cards to the list of existing components. Everything is green, there is some room for improvement. Enabling the compiler, and those are the numbers after. Which is still good, the number decreased, that's kind of cool. But also I expect much more because the list is really long, and if all re-renders were really eliminated, adding just a few cards to the list should have been close to instantaneous. So let's check the re-render situation again here. Oops, and unfortunately, lots of re-renders were eliminated, but the list still re-renders every single card. So what's going on here? What's with the code? At the first glance, nothing really that criminal. So I have an array of items. I map over this array of items, and then I render a card component. I even have correct keys and no arbitrary props. Everything is coming from the data array. So we need to investigate further. The very first thing that I do when I debug compiler issues is I'm trying to re-implement memoization with the classic tools, just to see whether the compiler bailed out from this code or not. So in this case, all I need to do is just to wrap gallery card in React Memo. And if the code is good, that means that then the existing cards in the list would have stopped re-rendering, and then that would mean that the compiler bailed from this particular component, which actually didn't happen when I've done it. So that means that the compiler actually worked pretty good, and it's not its fault. Something is really deeply wrong with the code itself. Again, I'm a really bad developer. But the code is the most standard code, the most standard React code that you can ever imagine. So if we try to solve it, as we already know, if even a single prop changes on a memoized component, then memoization will not work, and re-renders will still happen. So it's logical to assume here that something is wrong with the props. All of them are primitives except for this one. This is an object with strings inside. But also, it's still a little bit weird, because it's not I'm recreating this object every time. It's coming from data, and this data is coming from a data array that is from a data fetching library. So should I blame the data fetching library? Maybe it's doing something really weird. Let's take a look at the code again. What I have here is I give the library a key to identify cache entry, and then async function that it triggers when it doesn't have this cache entry that fetches the data for this particular key. If this hook is called with the same key during re-render, it returns the data from the cache. So the overfetching doesn't happen. So what is happening here in my case? I have a dynamic key. It depends on the selected filter. And then I have a fetch function that returns data, no merging or anything. When only the button is selected in the list, the key is this, the library returns an array that is associated with this key. If I turn on the checkbox, the key turns into this. the library returns a completely different set of data, a completely different array of data that is associated with this particular key. The library doesn't merge them together in any way, because how would it know? It relies on key to preserve data. I don't merge it in any way, because I never thought about this. And as a result, it's not the fault of the library. It does exactly what it should do. It does it really well. But I have now a situation with non-memoized component, or with memoized component, that has different objects on every re-render. So the easiest way to validate my assumption, to see whether it's wrong or not, is to turn this object into primitive props. If I do something like this, then in theory, memoized component will receive only primitive values, and re-renders on this component will stop. So now a bit of refactoring, clicking the checkbox. No more re-renders, no more unnecessary re-renders, only re-renders of checkbox cards. So let's measure it to make sure everything was worth it. This was before and after. Now to my numbers. And yes, humans still win. I feel like this is a mic drop situation. Robots will not take over the world anytime soon. So I'm going to add a trophy for me, because I obviously performed much better than a robot in this case. So this was interactions. I think it's safe to say that impact of the compiler is noticeable, but it varies from page to page, and humans are still better at memoization if they really, really try. So the final question. Can the compiler catch all re-renders? As we already have seen, the answer is probably no. But to test it a little bit more, I collected a list of most noticeable re-renders in my app and checked how many re-renders are still present after I enabled the compiler. So I had 9 cases of noticeable re-renders, stuff like the entire drawer re-renders when a tab changes. And this is the end result. So out of 9 cases, only 2 of them were completely solved. 2 of them, nothing was solved, and the rest of them were something in between, exactly as we just saw. 2 of the cases where nothing was solved were really weird, because the compiler just completely bailed from this file because of this line. The presence of this line alone just completely ruined everything. So the most likely reason for that would be this fuse search thing, which is an external library, is just doing something really incompatible with the compiler, unfortunately. And speaking of external libraries, they will never be transpiled by the compiler on your side, and this is in the docs. It's always going to be responsibility of external libraries to transform their own code. So if you're using a library that was not pre-compiled by the compiler, then there is nothing you can do. Re-render still will happen because of this library. I'm going to be mean and just take 1 award from the compiler, because the answer to whether the compiler can catch absolutely every re-render is definite no. I'm sorry, and it will never be. So there will always be external dependencies that are just incompatible with the compiler or with the memoization rules. There will be some really weird legacy code that the compiler just cannot process. Or there will be code like I had, which is not exactly bad, but just not fine-tuned for memoization. I actually tested the compiler on a few apps after that, and the results were almost identical. It catches between 50 and 90% of unnecessary re-renders, and it really depends on how large and complicated the component is. The more logic you have, the more complicated dependencies, the worse the compiler will perform. The simpler the code, the better it performs. So let's recap what we're investigating and how the compiler dealt with it. Initial load performance checks, I saw no negative impact.
Interactions, they improved. Some of them are really good, some of them just a little bit. Can it catch all re-renders? No. So does this mean that the answer to this question is, again, a no? Not necessarily, because it really depends, as always. If the performance of your app is not really the most important thing in the world, or if it's OK-ish, but it could be better, then enabling the compiler probably could make it good enough for a relatively low cost. What is the definition of good enough and low cost? It will be completely up to you. You would have to decide. But I suspect that for most people, turning on the compiler and just forgetting about memoization will be a good enough solution. However, if good enough is not really good for you, and you need to squeeze every millisecond out of your app, or if the cost is too high, welcome back to manual memoization. So for you, the answer will be, you cannot forget them, sorry. You would have to know that everything that you know right now, and then on top of that, what the compiler is, what it does, how it does it, and how to debug it. So your job will become harder, but also your job security will increase. So maybe a balance, who knows. So I hope this was good enough for the presentation. If you want to read more stuff about performance and memoization and re-renders, those are the links. And if you want a really cool cat theme stickers from this project, catch me up after the talk. I have a whole bunch of them. Thank you. Time for the questions.